about mole. The symbol. Scientists find it difficult to write long essays. Scientists don't write a lot, so they look for symbols to represent long words. So mole, instead of writing mole, you see scientists using N, small letter N. And then the unit for mole is MOL. Mole without E. The unit is mole. So example is 0.5 mole. Good. So I need you to note this. Now, once we know the definition, or we understand how we got mole, and we've also gotten the symbol and the unit, we need to move on to how to calculate for mole. So we are going to calculate for mole. Every quantity, if you want to calculate for every quantity, it comes with its formula. So we need to look at the mathematical expression for mole. So it's small n is equal to mass. Mass. You see scientists using small m per molar mass. You see scientists using capital letter M. So this is the mathematical expression for mole. This is the mathematical expression for mole. Now before I give you a direct question, it is easy to find the mass. The mass is always written with. So in a question, if I see that 6 grams, 1.3 grams, 20 grams, then I know that it represents the mass. But what about the molar mass? What about the molar mass? We need to look at the molar mass. Now, what you need to do is, anytime an examiner wants you to calculate for molar mass, it will give you the relative atomic number. So you see something like this, AR, and then give you maybe sodium 23, oxygen 16, hydrogen 1, chlorine 35.5. Good. You can consider this for now. So if I give you the compound 1, NaCl, sodium chloride, what you need to do is, if you are to of sodium chloride, you need to find the AR, the relative atomic number. Okay, as I was saying, you need to pick the relative atomic number of the first element, which is sodium Na, add it to the next compound. Okay, so as I was saying, when you are given a compound, sodium chloride, after writing or noting the relative atomic number of sodium, you are going to add it to the next element or atom, which is chlorine. So here we are going to use numbers. The relative atomic number of sodium is 23 plus relative atomic number of chlorine 35.5. So that gives us 58.5. Don't forget this unit, grams per mole. Grams per mole. One of the things that WAEC has realized is that most students get the answer, the figure correct, and they ignore the unit. Very soon, more marks will be deducted for ignoring the unit. So don't forget about the unit. Can we take more examples? Let's take more examples. C6, A12, O6. Yeah, this is very popular. This is a popular compound used by athletes. I'm sure you've remembered. Glucose. Let's try and calculate the molar mass for glucose. What we need to do is we need to look at, okay, here I did not provide for carbon. Carbon is 12. So here I want you to observe this. Carbon is 12. The relative atomic number of carbon is 12. How many carbon atoms here? Because the 12 is just for each carbon atom. And here, how many are here? 6. So 6 plus hydrogen is 1. How many are here? 12 plus oxygen is 16. How many oxygen atoms are here? 6. So what I want you to do is you multiply 6 by 12 and then you add it to 12 and then you add it to 6 by 16 and then let me see. Okay, so once you are doing it, I'll add something. I'll add another example. That will be the third example. Yes, this compound. This compound. Yes. Copper 2 tetraoxosulfate 6. And then I told you science is a friend to Latin. In Latin, 5 means penta. So copper 2 tetraoxosulfate 6 pentahydrate. Good. That's why you pack. But let's see how we calculate this. So I'm going to give you this. Sulfur is 32, oxygen is 16, hydrogen is 1, copper is what? 64. Okay, let's use this for now. So we have copper SO4.5. Good, water. So copper, we've been given 64. Whatever that you are given, use it. Plus sulfur 32 plus oxygen 16. Here we can't just write 16. There are 4 atoms of oxygen. So 16 times 4 plus, yes, don't be tricked. Yeah, it's dot pentahydrate, but it's plus 5. Then this is into bracket 1. Hydrogen is 1. Hydrogen is 1. How many atoms of hydrogens are there? 2. Plus oxygen is 16. Oxygen is 16. Good. So we'll get 64, 32. That will give us 96 plus, is it 68? 46. Okay, and then this is 5 into bracket 18. Good. What was the answer for the first one? The glucose. 180. Good. Grams per mole. Don't forget, grams per mole. So I'm sure you will also work on this for me. Don't forget the unit, grams per mole, 180 grams per mole. Okay, 250 grams per mole. Grams per mole. So this is how we calculate for molar mass. This is how we calculate for molar mass. You need to master it. You need to master it. I've given you sodium chloride, I've given you glucose, and I've given you copper sulfate, copper 2 tetrahydrogen sulfate, pentahydrate. Yes. So this is how you calculate for molar mass. Can we apply this in a typical mole question? Let's apply it in a typical mole question. In a typical mole question, we know that mole is equal to small m over big M. So let's apply it. My question is simple. How many moles are in 12 grams of hydrogen chloride? 12 grams of hydrogen chloride. Then I have AR, relative atomic number of hydrogen is 1. Chlorine is 35.5. Good. Now there's one trick here. Science, when you're doing calculations in science, you meet a lot of formulas. My advice to you is always quote the formula when you are solving a question. So this question, for instance, I'm going to quote my formula. How many moles? So N is equal to small m over big M. Now, my small m mass has been quoted here, 12. So 12 grams per divided by the molar mass. I need to go and calculate my molar mass and then come and put the answer here. So molar mass of HCl, hydrochloric acid, which is simply hydrogen is 1 plus chlorine 35.5, which was given. So it is 36.5. So we have 12 grams divided by 36.5 grams per mole. Now I want you to pick your calculators and then do this for me. 12 divided by 36. 12 divided by 36. Don't forget the 0.5. 12 divided by 36.5. Do it for me. The gram will cancel the gram. So any answer that you get for me, I'm going to leave it in moles. And that's the unit for 0.32. That's okay. Okay, 328. 0.328. So I'll round this up to 0.33. So 0.33 moles. This is how we calculate for moles. This is how we calculate for moles. I want you to also note this. We realize that in this question, we're asked to find moles. But there could be another question, or there are lots of questions, past questions, whereby the mole will be given, and then you need to find the mass. You need to find the mass. All you need to do is to make the mass or the small m the subject. I knew you would try it, and then if there are any challenges, you let us know. I really want us to look at this. How we got the mole. Look at this diagram again. You realize that whatever that was here was called mole, and we defined it. Now there's one question I want us to ask. I want us to ask ourselves. The question I want us to ask is that you look at this part and then it contains atoms. But the question is, how many atoms are there? How many atoms are there? That is the answer that this gentleman called Avogadro came to give. He gave an answer to that. So all that he did was to pick what we call the mole and started counting 1, 2, 3, 4, 5 to know the number of atoms that were placed here. And when he did that, he had this constant 6.02 times 10 exponent 23 atoms. So you remember that this was referred to as Avogadro's constant, or if this is your first time, then 6.02 times 10 exponent 23 atoms is also called Avogadro's constant. Avogadro's constant. It simply means number of atoms in a mole. So this is 1 mole or a mole, the number of atoms that were placed here. And this is what we had. The symbol is N, I mean capital N, N. And its mathematical expression with respect to mole is simply, you see most, in other books you may see N, then they bring the A, or you can also see this, Avogadro's constant, but we can stick to this for now, Na. Now the mathematical expression is N is equal to small n times L, or, okay, let me use it here, or N is equal to small n and this, but I would prefer the first one. That's quite easy. So if you want the number of atoms, then you multiply the mole by the Avogadro's constant. I think we should look at one example. We should look at one example on Avogadro. What we need to look at is how many atoms are in 2 moles. How many atoms are in 2 moles of water? And then this formula must not, or this constant must not be memorized. It is always quoted. If you have to use it, any examiner will give it to you. So how many atoms? So the formula N is equal to small n times Avogadro's constant. How many atoms? The N. Then the mole has been quoted, 2. So 2 times L. I don't really want to call it L, but it stands for Avogadro's constant. 6.02 times 10 exponent 23. You pick your calculators and then do that for me. One point two zero four times 10 to the power 24. Okay. That's 12. Yeah. Atoms. Because we asked how many atoms. Good. Sure. Good. So we end today's section. But there's one thing I want you to do. If you really enjoyed this video, you need to go to YouTube and subscribe. Please subscribe to this for us so that we can bring more episodes to help you and then your brothers. Thank you.